For a right triangle, if you take the adjacent cathetus to an angle and divide that by the hypotenuse, that you call the cosine of the angle. So that's just a symbol for this quotient. So this divided by that. Similarly, if you take the opposite cathetus and divide by the hypotenuse, then you call that quotient for the sine of V. And if you take the opposite divided by the adjacent cathetus, the quotient of those, then you call that the tangents of the angle. It's easy to see that this definition doesn't depend on which right triangle you choose. The only important thing that this angle should be same. So if you take another triangle, a larger one or a smaller one with the same angle here, these quotients will be the same for the two triangles. So this definition only depends on the angles, not on the size of which choice of triangle that has this angle. And of course it has to be a right triangle. Defining like this, then cosine will be a number between 0 and 1. And the same for sine of V. That will also be a number between 0 and 1. And tangents will be a number between 0 and infinity. Note that we can also write tangents of V as sine of V divided by cosine of V. And why is that? Because if you have sine of V divided by cosine of V, if you look here in the definitions, this is B divided by C, and cosine is A divided by C. You see that the C cancel, so you're only left with B divided by A, but that's tangents. So therefore you also have this relation. For some right triangles you can calculate sine, cosine and tangents exactly. And those cases are, for example, if you have a right triangle with degrees 45 here or 30, 60. So for example, if you have this 45, 45, 90, then you see that these two must be identical. So let's say let's call this for A. And then B is equal to A. And what is then this hypotenuse equal to? That we can determine by Pythagoras theorem. So we have that A squared plus A squared must equal C squared. So we have 2A squared equal to C squared. So C is equal to square root of A. So here we have the square root of A. And then we have that, for example, sine of 45 degrees. Then we should take this cathetus divided by the hypotenuse. So A divided by square root of 2A. This is just 1 over square root of 2. So here we have an exact value. If we want an approximate estimate, we could just plug it into a calculator. But this is an exact value of sine 45. And we see that for cosine 45, we have the same. Since cosine 45, we should take this divided by the hypotenuse, but that will be the same fraction. So it will also be 1 over square root of 2. And if you calculate tangents 45, then we should take this divided by this, but that's of course equal to 1. So for this special case of 45 degrees, we can calculate sine, cosine and tangents exactly. But also for this special case here. Because if you extend this one, you take the mirror image here of this one. You will see that here is 60. And here is 30. Then you see we have 60 here, 60 here, 60 here. And then you have a triangle that is equilateral. So 60, 60, 60. That means that all sides must be the same. So now we can call this C. Then this side is also C. And this is C. But for our original triangle, that means that we have that this side is then C half. And what is the height of the triangle then? Let's call it H. Then we can also find out about Pythagoras theorem. So we have that C squared here, the hypotenuse, is equal to H squared plus this squared here. And then we get H squared plus C squared divided by 4. And if we move over C squared here, so we have 3/4 C squared equal to H squared. So H is equal to square root of that. So that is square root of 3/4 C. But that is just square root of 3. Square root of 4, but that's 2. So it's this. So we have that the height is this. Okay, but then we can calculate the cosine, sine, and tangents for 30, 60 degrees also. Okay, so we have this triangle with these sides followed from here. Then we can calculate, for example, sine of 30 degrees. That's equal to this divided by this. So C half divided by C, and that's just a half. So sine 30 degrees is a half. Cosine 30 degrees is this divided by this. So it's this. This is just square root of 3 divided by 2. And tangents 30 degrees. That is just this divided by this. So this is just 1 over square root of 3 after we simplify. Then in the same way we can calculate for sine 60 degrees, cosine 60 degrees, and tangent 60 degrees. So sine 60 degrees, we should have this angle. Then it's this one divided by that one. So this is just square root of 3 divided by 2. And sine of this is, a cosine of that is this one divided by that one. So that's a half. So we see that that one corresponds to that one, that corresponds to that one. So we have the opposite between these 30 and 60. And then for tangent 60 degrees, we should have this one divided by that one. And we see that this is just square root of 3. So if you have angles 45, 30, or 60, or 90 degrees, but we'll come back to that later. But if you have one of these three, then we can calculate exactly the values of sine and cosine. There are also other angles you can calculate exactly, but generally you can use a calculator. So if you want to find out, for example, what is sine of 43 degrees, then you can plug this into a calculator and get an estimate of that, or approximate value of that. Okay, so let's take an example. Let's consider the following triangle. So we have this right triangle with the height of h here, angle 30 degrees here, and we know this is 6. Now we want to determine the height. So what is the height? Then we can use trigonometry. So we can take sine of 30 degrees. And why sine? Because that involves this one and this one. So sine of 30 degrees is this divided by that. So we have like this. But then we can solve out for h. We can write this as 6 times sine of 30 degrees. That's h. But now we have just seen how to calculate sine of 30 degrees. It's just 1/2. So this is just 6 times a half. So then we know that the height is 3. So that you can find out by trigonometry. Let's take another example. Let's see that you're standing here on the shoreline and you see a bather or swimmer out here, and you want to find out what's the distance to this person here from you. So let's say this is 30 degrees and this here is a right triangle, and let's say that you walk here 150 meters, then you come at a right angle to the swimmer here. You are as close as possible to the swimmer. So, okay, so how far out in the water? What is this distance here? And that you can calculate by trigonometry. And then you can use, for example, then cosine 30 degrees. And what's that? That's this side here, 150, divided by the distance, hypotenuse. And then you can solve for d. And you can just write this as 150 divided by cosine 30 degrees. And now you only have to look at here, remember what this was. Square root of 3 divided by 2. So this is square root of 3 divided by 2. And 150 divided by that. So this is 300 if we treat it as fractional division. This is this. And here you can use a calculator, and you will see that this is approximately 173 meters. So the distance here is 173 meters. That you can find out by trigonometry. Let's say you want to find out the distance from Earth to the Moon. So you want to find out this distance A. So if you're standing on the Earth here. Okay, the Moon has a diameter of 347,000 kilometers. 3,470 kilometers. So that's the diameter of the Moon. Seen from Earth, then the Moon takes up half a degree of an angle seen from Earth here. Okay, so we have the distance here A, and then we have D here, that's the diameter of the Moon. And then we want to determine A. Okay, so we know here that V is a half a degree. Then we can use trigonometry. Okay, so we have that tangents for half of this. So this part here, half of V, that is this part, the radius. So that's radius or diameter divided by 2, divided by the distance A. Okay, so we have that tangents V half, V is 0.5, so this is 0.25 degrees. And half of that is this. Then we can solve for A. So we have that A is equal to, so if you calculate what this is, 1,735 divided by tangents 0.5 degrees. And then we can use a calculator to calculate this, because this doesn't correspond to any known exact value. And if you use a calculator, this will give us, depending how many decimals you want to keep. But let's say we keep this many. Then the distance is this. You could compare with the diameter of Earth, and that is roughly 12,740. So this is 394,000. This is 12,000 something. So you can compare here. You can also compare them in the figure. And if you want to draw them to scale, you see you have the Earth here, then the Moon is this size, and then the distance between Earth and Moon is this. Let's take one final example. So if you have this right triangle, let's say we want to determine the angle V here. So how can we do that? We can start by using sine for V, and that is this divided by 10. 3 divided by 10. So 0.3. Then we can use a calculator, because there's no, we don't know any angle that corresponds to this directly. It's not one of the typical values, 45, 30, and 60. So we can use a calculator. And by using a calculator, if you press the button that says sine minus 1, and that means the inverse of this, meaning that if you have the sine value, that will give you the angle. So the angle is given by the inverse of sine. And then you plug in 0.3. Then the calculator will give you 7.5 degrees. So that's, if you have sine, you can calculate the angle as the inverse of sine, the inverse function. In the same way, you can find angles using cosine and tangents by using the corresponding buttons for that, so the inverses of cosine and tangents. Another way of writing sine, the inverse of this, is write arc sine. So that's another name for sine inverse, sine minus 1. And same for cos minus 1, that's arc cos and arc tangent. Note that this does not mean, for example, cosine minus 1 does not mean 1 over cosine. This does not mean that. This indicates that it's in inverse, the inverse function. So if you have an inverse function, you denote it by a minus 1. So this does not mean 1 over f. So this is just a symbol.